Hello Gems! Welcome back to the Super 30 series. In this series, with every video, we are discussing 30 most probable questions for BITSAT 2024. This is session 3. In previous two sessions, we discussed 30 questions each. In this, we are going to discuss 30 more. So this is a series which will go on for a few months now. So by the end of the series, you'll have about 10 such videos, meaning 300 most probable questions for BITSAT 2024. Okay, so if you want to join in, consider subscribing and just join in for free. Okay, so and if you have missed the previous two sessions, the links will be available. The playlist link is available in the description box of this video. So with that being said, let's begin with today's video. Question 1 that will start our session today is: an aeroplane is flying in the horizontal direction, of course not on the ground, it is flying parallel to the ground in the horizontal direction with some velocity u. It is at a height of 2000 meters or 2 kilometers from the ground. Okay, so this is the scenario. So at a point A, what is happening at a point A on the ground? At this point, when this plane is just vertically above this point, a food packet is released from it. Okay, a food packet will be released from the plane. Now the trajectory of that food packet will be somewhat like this, right? It will retain the velocity from the plane and it will go under the effect of gravity like that, right? Projectile. Okay, so here it will strike the ground at some other point which is called as B, and this distance AB is given as 3 kilometers. Okay, you are supposed to tell what is the velocity u over here. Okay, it's very simple actually. You can break the motion in x direction. You can see it in the x direction and in the y direction. Okay, let's do that and you'll learn the approach as we do it. So in the y direction we can apply. So in the y direction you can see that the displacement is in the y direction. If you see, the displacement is nothing but the height, right, which is 2000 meters. Okay, the food packet is covering 2000 meters in the y direction. Okay, and the useful information here is that we can compute time. Okay, so from distance we want to go to time. We can use the equation Sy is equal to Uy. I'm using it in y direction, so that's why I'm using the subscript y over here. Okay, so we can use this equation S is equal to ut plus half at square, because from distance we want to go to, from displacement we want to go to time. Okay, so we want to know what is the time taken for the packet to cover those 2000 meters in y, right? So here Sy is 2000, Uy, the initial velocity in the y direction 0, right, because the plane is traveling in the horizontal direction, right? So the packet is also traveling purely in the horizontal direction. Initial velocity in the y direction is 0. Okay, the packet is traveling with the plane in with velocity u in the x direction. There is no y component over there. Okay, so this effectively becomes 0 and we are left with half ay. We can take ay as g, which is 10, and t square. Okay, so we can cancel this. This will be 400. 400 is t square, meaning t is 20 plus or minus, but time can be only positive. So t is 20 seconds. So which means it takes 20 seconds for your packet to reach the ground, right? To cover this height, 20 seconds, right? And effectively, it's also the time the packet takes to move this distance in the x direction, right? Or you can think that time is independent of frame of reference. Okay, whether if you see the motion in x direction or in y direction, the time is going to remain the same. Okay, the other quantities, displacement, velocity, may not remain same, but time will be same in both the directions, x direction as well as y direction, because this is the time that it takes in the y direction. Okay, and effectively it is reaching over here. Okay, so it's covering this distance in x, and if it has to reach point B, it has to also cover the same the 3 kilometers in the x direction during the same time. Okay, so that is the key point over here. Time is independent of frame of reference. That is what I mean. Okay, so we can use the same time t in the x direction also. And in x direction, the case is simple because it is just distance is equal to speed into time. Because here in the x direction, there is no force, right? In the y direction, there is gravity, right? But in the x direction, there is no force on the particle. It's just pure velocity. So you can simply use s is equal to ut. The acceleration is 0. Okay, so distance, we know distance in the x direction is 3000 meters. S, which is the speed which we are supposed to find, into time. Time is 20 seconds, because it takes 20 seconds to cover this distance. okay, 20 seconds to cover this total thing, okay, so in y direction and in x direction, that's why it reaches here, right? So this will cancel and you will get as 150 meters per second. Now some of you might forget about the units and you might just see that the answer is 150 and tick here, okay, it's not the correct answer over here. 150 meters per second, please remember the units, okay. And if you see, all the answers in the options are given in kilometer per hour. So if you want to convert, you have to multiply by 18 by 5, right? So if you want to convert meters per second to kilometer per hour, you have to multiply by 18 by 5. So meters per second into 18 by 5 will give you kilometers per hour. This is something that you should remember, or you might know it the other way around. Usually you convert kilometers per hour to meters per second, right? So in that case you multiply 5 by 18, okay. So here this will be 30, right? 5 3s are 15 and 18 3s is 54. So 54 and 0, which is kilometers per hour, 540 kilometers per hour, okay. So that is our answer. Let's move to the next question. So here in question 2, we are supposed to tell which of the graph correctly represents the variation of your potential with the distance, okay, distance from the center for a non-conducting charge sphere, okay. Now let us proceed by the method of elimination, okay. We'll get to our answer eventually. So if you see this graph number 1, here if you see here, okay, it's fine. Beyond R it is fine because it is an inverse relation, of course. Outside the sphere it is inverse relation, but inside the sphere it won't be constant, right? This is a solid non-conducting sphere, okay. So the charges will not come to the surface, they will remain inside the sphere, okay. The sphere is non-conducting, so the charges will remain inside the sphere, okay. So the potential inside the sphere will not be constant, okay. So inside the sphere it is not constant. This is the case for your hollow sphere, okay, or a conducting solid sphere, okay. This is a solid non-conducting sphere, okay. Let's come to this one. Here if you see, it's linear and linearly up and linearly down, which is not true. Of course outside the sphere it varies as 1 over r, right, kq by r, okay. Let's come to this one. Outside the sphere it is correct. Inside the sphere it is saying that the potential should be linear. Actually this is not the case, okay. So for those who picked this as the correct answer, you were close but not good enough, okay. The correct answer over here is option D, okay. I'll justify because the relation for potential for a solid non-conducting sphere we actually derived in one of the one-shot classes, right. So it is 1 kq by r cube into 1.5 r square minus 0.5 r square. This small r square is the distance from the center, okay, and capital R is the radius, of course, like given over here, okay. So if you see at r is equal to 0, first of all you can verify this, that v is proportional to minus r square, right. V is proportional, these are all constant. If you see, it is some constant minus and constant plus this proportional to minus r square, right. So this should be some parabola, right. So only graph that you see a parabola over here in the first region is this, right. The first region is satisfied by this. You can also see that the value will be a value of this here will be greater than the value on the surface. You can see that at r is equal to 0, if you plug in r is equal to 0, you get kq by r cube into 1.5 r square, right. This term will become 0, r square, and this will get cancelled. So this becomes 1.5 kq by r, okay. So kq by r is the potential on the surface, okay, at distance r. So this is 1.5 times that, okay. So if you see the potential at r is equal to 0 is greater than the potential at the surface by 1.5 times, okay. This can also be one question. What is the potential on the center of the non-conducting sphere, okay. So this is the correct plot, and of course after for r greater than or equal to r for distances outside the radius, the potential is basically, or I should write like this, the potential is basically kq by r, right, inverse relation. So that is also checked, and option D is the correct choice over here. This is the graph of electric field versus r, okay. Electric field increases linearly for a solid non-conducting sphere. For potential it is somewhat like this. If you can also relate it with the gravitational potential of solid sphere, okay, if you know. Anyways, that's question 2 for you. Let's move to the next question. So question number 3, here we have a machine gun. I mean, we don't have a machine gun, or I might be somebody who is teaching physics on YouTube and making bombs in my backyard. Who knows? Okay, so that is so not true. Okay, don't arrest me. Let's come to the question. We have a machine gun. I mean, in the question it's mentioned there is a machine gun which is firing 300 bullets per minute, and the mass of each bullet is 10 grams. The velocity with which the bullets are released is 600 meters per second. The power of the gun is. As a physicist and a terrorist, I wish to solve it. Okay, that is not true, by the way. Okay, I'm just a terrorist. I'm just a physicist. Let's come to the question. So there are not two ways about it. Actually, we can do it by the work energy theorem. Okay, so work done by all the forces is, as you might know, is change in the kinetic energy. So work done by all the forces is equal to change in kinetic energy. Okay, so basically we have to find power, right? So we can say it's work by average power will be work by time taken, right? So work you can find using change in kinetic energy. Okay, so kinetic energy, so initially of course the gun is at rest, so initial kinetic energy is 0, so you just have to find the final kinetic energy, which will be given as half mv square. This is for a single bullet and we'll multiply it by n, the number of bullets. So let's do that and let us compute this value. Half m, what is m? 10 grams, 10 into 10 to the power minus 3, and v square, v is what, velocity, which is 600, and that is squared into n, number of bullets 300. So it is somewhat like this. So let us solve this. What do we get? So this is, if you see, this 10 to the power 2, 10 to the power 3, 10 to the power minus 3. Okay, this is fine. 3 into 36 we can say, and this is 10 to the power 4, and this is half, and this will be 18, right? 18 3 is 54, 54 into 10 to the power 4. That is the amount of work. Okay, now that work is done in 1 minute, right? 300 bullets per minute. So that you have to divide by the time, which is 1 minute, right? 1 minute is 60 seconds. So 60, okay? Or I can say this is 540 into 10 to the power 3, because I want the answer in kilovolts, so kilowatt, watt, whatever. So I'm bringing it in that terms, okay? So 6 9s are 54, you can see that. So 69s are 540, so 9 kilowatt. Okay, so 9 kilowatt, option B is the correct choice over here. Over to the next question. So let's come to question number 4. Here we have been given that the de Broglie wavelength or de Broglie wavelength of an electron moving with a velocity c by 3, where c is the speed of light, is equal to the wavelength of a photon. Okay, the ratio of the kinetic energy of electron to that of photon. Okay, so kinetic energy of electron to kinetic energy of photon, that is what we are supposed to find. Okay, this ratio we are supposed to find. Okay, so if we see, we are being given that the de Broglie wavelength of our electron is equal to that of the wavelength of photon. From here we can conclude that their momentums are equal, okay, because the de Broglie wavelength is basically h by p, right? So h is a constant, so you can cancel it out on both sides. So here the momentum of electron is equal to the momentum of your photon particle. Okay, so here that is what we get, or we can say that mv is mp vp, right? These two momentums are equal, mass into velocity for electron, for photon. Okay, so here mass of electron, so our objective over here is, so if you see, this will be half MEVE square, and here half MEV VP square, right? Or you could have written it in terms of potential also. Okay, so actually that will be easier. So we can write kinetic energy as P square by 2m, right? You can also do it the other way, which I mentioned. So P square by 2m. So from here you can directly conclude that it is inversely proportional to m, right? Because P is constant, we know both will have the same momentum, same de Broglie wavelength, hence same momentum. So when you take the ratio, the p square will cancel out. Okay, it is inversely proportional to mass. So for electron, mass is inversely proportional, and for photon, it's inverse relation. Okay, so you can see the inverse relation over here. So you are just supposed to find this effectively. Okay, or you can do it the half MEV square that way also. So that you have to only know the ratios of this VE and ME, same thing. Okay, so anyways, let's do it now. So VE, the velocity of electron, is given as c by 3. C is the velocity of light, and this is mass of photon, and of course photon is moving, so of course the mass will be not 0, rest mass is 0, right? So this is c, and this is c by 3, and this will be c, right? Photon is nothing but light particle, so it has velocity of light, speed of light. Okay, so if you see, we want mp by me, so mp by me will be 1/3, right? So this is nothing but the ratio that we want. This is 1/3, which is option B, 1/3. Okay, so that is our answer. I hope it was simple. And one more thing which I wanted to mention, it's not about the question. I wanted to ask you all whether you all like it in this format. Okay, so in the previous videos, if you have watched in session 1 and 2, we used to discuss 2 questions at a time, right? So it used to become a bit messy, I would say. So do you all like discussing this it this way, 1 question at a time, or do you all want to go back to the 2 question at a time approach? Okay, do let me know in the comment section. I prefer this. You let me know your say, and let's figure it out. Okay, so that's about this question. Let's move to the next one. So question 5 over here. Here we are given that a wheel is rotating at this frequency. Okay, about its axis. The power is cut off, and it will come to rest in 1 minute. You are supposed to tell what will be the angular retardation. Okay, so you are supposed to tell alpha. Okay, that's why it is in radians per second square, right? So that will be delta omega by delta t. Average alpha is change in the angular velocity by time taken, just like your acceleration is change in velocity by time. Okay, so this is just the angular analog, right? So if you see here, we are given this is nothing but nu. Okay, this is not omega, this is nu, frequency. Okay, this is not angular frequency, it's just frequency. Okay, you can make it out from the units, RPM, RPS. Those units are for frequency, normal frequency. Okay, and omega will be in radians per second. Okay, so how do you get from nu to omega? Omega will be given as 2 pi nu, right? So 2 pi nu. So what will be the answer over here? So actually 900, we have to convert that into, that is rotations per minute, right? So do we convert? Okay, let's convert. So this and this will get cancelled. This is 2 3s are 3 30s are, right? 30 pi. Okay, so this is our initial omega. Omega initial, omega final is 0, right? Omega final will be 0 because it comes to rest. So omega final is 0. This is basically omega final minus omega initial upon delta t. Okay, so omega final is 0, omega initial is 30, so minus 30 pi upon our time taken, which is 1 minute. That's why I didn't wanted to convert. Minute could have gotten cancelled. I think so. But anyways, let's come to this. Delta t is 1 minute, which is 60 seconds. Okay, so here we get pi by 2. Okay, minus sign because it is retardation, right? So it is stopping the motion. Okay, it is slowing down the motion. It is bringing it to 0. So option A, pi by 2, is the correct choice over here. Okay, so simple direct application of the formula. Okay, so you just didn't have to confuse this with omega. This is nu. Okay, so that is our answer. Over to the next question. So let's come to question 6 over here. Here we are given 2 wires of the same material having their radii in the ratio 1:2. They carry some current which are now currents are in the ratio 4:1. They are supposed to tell the ratio of drift speed. Okay, it's actually very simple. You are just supposed to know the relation between your current and your drift speed. Okay, which is given as I is equal to NEA VD. Okay, this is current, this is drift speed. This relation, if you know, the question is very simple. Okay, you are just supposed to find VD1 by VD2, or you can actually take I1 by I2. Okay, in this are representing 2 wires. I can say A and B. That will be better because those are wires A and B. So Ne will be same in both the wires, right? Because it is the same material. For same material, actually if you see the resistivity relation is M by Ne square tau. From here you can see for the same material resistivity is same, because this nothing of this changes, right? So Ne does not change for the same material. For E is same. If you see Ne, E is the very charge on the electron, which is a fixed value. N is the density or the number of electrons, right? So that will not change when you if you don't change the material. Okay, free electrons will remain the same. So any will get cancelled. So we'll have area of A. I'll write small a and B. Okay, don't confuse. It's the same wires A and B. I'm saying. Okay, so this is area of B, and this is velocity, drift velocity of A upon drift velocity of B. This is what we are going to get, right? So we want to find this ratio VA by VB. Now current in the ratio, it is given 4:1. Current in A is to B. Okay, this is the ratio A is to B. So A is to B is 4/1. Now area is pi r square, right? Or I can say area is proportional to r square. So RA by RB square I can say, and this is VA by VB. So this is 4, and here radius is in the ratio 1:2 for A and B. Okay, so 1:2. So 1 by 2, and that is squared, and this is VA by VB. So from here you can easily see VA by VB will be, this will become 1/4. Go to the other side, it is 4 4s are 16. 16:1. Okay, so the correct choice over here is option A, 16:1. Okay, when in doubt, choose option A. Statistically, actually, when I've gone through the papers, and usually the correct answer is option A. Okay, don't use that information wrong, but when in doubt, you can actually select option A. Okay, anyways, don't blame me if you get it incorrect, but that's about this question. Over to the next one. So question 7 from thermal physics this time. Now this is a very simple question, and I'm not even making this up. This is a question which was asked recently in BITSAT. Okay, I think it was BITSAT 2023, but this is a question from one of the BITSAT papers. Okay, so here we are given two ends of the rod of length L, uniform cross section A, are kept at temperatures. So one end is kept at T1, other one is at T2, T1 greater than T2. The rate of heat transfer dq by dt through the rod in a steady state is given by. Okay, if you know the formula, you know that the direct answer over here is this one, right? Ka delta T by L, right? The heat transfer or the heat current as we call it, which is basically dq by dt, the transfer rate of heat, is nothing but Ka delta T by L, cat by L, you can see, right? I also noticed it today. Okay, so Ka delta T by L. Okay, so if you or you can imagine it with intuition that this heat current or the rate of heat will be inversely proportional to length, right? Because higher the length, less current, heat current or heat will flow through your rod, and greater the area, the more heat can flow through the rod, right? Greater the area, the greater amount of heat can flow through that rod. Okay, so this, the relation will be somewhat like this. Okay, so from intuition also it is suggesting you this answer which is in front of you, and this is a direct formula which is there in your NCERT, right? Or you can also use dimensional analysis, but that would be very tricky. Okay, because if you see they are messing around with the terms, you can use dimensional analysis on each one of them and find which one has the dimensions of this dq by dt. Okay, that is also a way, but that is very tedious because you must know the dimension of each of this. K is also dimensional, I believe, I think, yeah, thermal conductivity. So you must know the dimensions of each of them. Okay, so that is your direct straightforward answer, a formula that is in your NCERT. So I would suggest that you stress on your formulae for BITSAT. Okay, formulae are important. There will be at least one formula based question, not like this, but there will be one formula based question wherein they'll give you all the values. You are just supposed to know the formula and substitute it. Okay, so if you're lucky, you'll get more such questions in your shift. Okay, 1 to 3, maximum 3, not above that. Okay, most questions will be conceptual, but at least 1, 2 or maximum 3 can be formulae based. Okay, so that's about this question. Over to the next one. So question 8 over here, this is from semiconductors, as you can see. So semiconductors is actually an important topic for BITSAT. Okay, it might not be that important for JEE, but it is important for BITSAT, especially if you see the recent papers. Okay, if you go through the recent papers like from 2016 onwards, you'll see that there is at least one question from the semiconductor and the communication topic. Okay, so don't skip it. It is important for BITSAT. Okay, so let's come to this question. Here we have a circuit. The diode in the circuit is assumed to be an ideal one. Okay, so when Vi is increased, when Vi, this input voltage, uh, messed up. Okay, this is not -2. This is Vi over here on this terminal. So Vi is increased from -2. So initial value is -2. Finally, it is made 6 volt. The change in the current will be, okay. I'll explain you the question here. Vi, first we are going to keep it at -2. Then we are going to find out the current. Suppose that is I1. Okay. Then we are going to keep Vi at 6 volts, and then we are going to find I2. Okay, so I1 minus I2, this change is what we are supposed to report. Okay, so Vi initially is -2 volts. So if you see Vi is -2, then the PN junction will be reverse bias. This will become reverse bias, right? The diode will get reverse bias because this one is -2. -2 is connected to the positive of the diode. This triangle represents positive, line is the negative. So negative is at a higher potential. Okay, in this case. Okay, so in that case, this is reverse bias, and in reverse bias, the current through the diode is 0. Right? The diode will just short. It will become open circuit. Okay, so this will give us the current as 0. Okay, no current will flow. It's open circuit. Okay, let's come to this one. When the voltage becomes 6 volts over here, we can draw the equivalent circuit. It will be basically replaced. Now if you see, this will be forward bias, right? Because we have the positive, the P part is connected with a higher voltage, +6. This is +1. Okay, P is at a higher potential. Higher potential meaning you just have to ignore the diode. It will get short circuit. Okay, it's 0 resistance. Okay, it will allow the current to flow. So 6 volts. Here it becomes 1 volt, and this is 250. Now it is so simple. I2 will be delta V by R. Okay, I hope you got how we got over here, because this is at a higher potential, this is at a lower potential. Positive at a higher potential meaning forward bias. Forward bias meaning you can just ignore the diode. Okay, in reverse bias it becomes an open circuit. In forward bias it becomes a short circuit. Okay, you just connect a wire. Okay, so that is what we did. So here I2 will be V by R, the change in potential, which is 5, 6 minus 1, 5 upon 250, the resistance, right? So this will become 1 by 50. 1 by 50 is 0.2, right? 0.2 milli. Okay, so 0.2 into 1 by 5 is 0.2. So this is 0.02. Okay, so that will be, if you want it in milliamps, it will be 20 milliamps. 1, 2, and 3, right? So it will be 20 milliamps. We want the answer in milliamps, right? So option B, 20 milliamps, is the correct choice over here. I hope the approach was simple. Let's move to the next one. So let's come to question 9 over here. Here we are given that the compressibility of water is this per unit of your atmospheric pressure. You are supposed to report the decrease in the volume of 100 centimeter cube of water. This is the volume of water which is given, which is under a pressure of 100 atmosphere now. Okay, so only thing that you are supposed to know over here is that this compressibility is nothing but 1 over bulk modulus, and you are also supposed to know the formula for bulk modulus, which is P V by delta V, and of course with the minus sign, which basically denotes that the change in the volume will be negative. Okay, if you don't know this formula, okay, let's begin with scratch. Okay, let's begin. Suppose you don't know anything except that the compressibility is 1 over bulk modulus. Okay, you can derive the formula for bulk modulus, any type of modulus. So this is how we begin. This is Physics for Idiots, episode 1, me being the first one. Okay, anyways, so here the bulk modulus will be basically any type of modulus is stress by strain, right? So stress is force per unit area. So force per unit area, stress, and strain is change in the dimension to the original dimension. Here what are we speaking of? Volume, right? So change in volume to original volume. Now force per unit area is nothing but pressure, okay, and this V will go on top, and we have delta V in the denominator, okay. And what we are supposed to report over here, so finally the formula for bulk modulus is this. So delta V will be PV by B, okay. We are supposed to report delta V, right, the decrease in the volume, yes, delta V. So PV by B, or PV into 1 by B we can say, or we can say PV K, right, 1 by B is K. Okay, so let's substitute and get our answer. This should not have taken that long. P is pressure in this case is 100 atmospheres into CGS unit, so we'll keep it in that unit only. Volume is 100 centimeter cube, okay, so CGS only I am keeping, okay, and K is this 4 into 10 to the power minus 5, okay, this is 10 to the power 4, right, so this will be 0.4, and unit, this is volume, right, volume is centimeter cube, okay. So 0.4 centimeter cube. Option A, when in doubt choose option A, that's your correct choice. Let's move to the next one. So question 10 over here, from alternating currents. Now this is also a formula based question. You are just supposed to know the value of Q factor for a RLC circuit. Also they have provided you with the resonance condition. You are just supposed to tell what is the value of Q factor. How do you actually define Q factor? Okay, so it's a direct formula based question, right? The value of Q factor, the correct expression for Q factor over here is omega L by R. Okay, there is no two ways about it, right? That is the answer, okay? So this type of questions are recently asked in BITSAT. I don't know why, but they did appear in your recent BITSAT papers, okay? So please learn the formula properly. Also, I'll give you a trick to remember this Q factor. It is actually XL by R, okay? This is how I remember it. XL is nothing but the impedance due to the inductor, which is omega naught L, right? So if you didn't knew this formula, anyways, if you didn't knew XL, it is not going to help you. But if you did knew that XL is omega naught L, you can remember the Q factor in this short way. Okay, it's the ratio of two resistances, you can say. One is the impedance due to your inductor, and one is due to your resistor. Okay, so that's your answer. Over to next one. Let's come to question 11 over here. Here we are supposed to tell the center of mass from the wall, the distance of center of mass from the wall for this system. Each of this is a brick of mass m and length is L. They are arranged as shown, and this is the wall we are speaking about. Okay, we are supposed to tell what is the distance of the center of mass RCOM from the wall. Okay, now instead of treating them as bricks, we can treat them as discrete points, right, as a discrete mass. Okay, by making each of them, okay, by considering each the center of mass of each of the block. Okay, so now for this first block, the center of mass will be at the center at a distance L by 2. So this is the mass m over here. Then for this one, again we'll have center of mass at this point, right, at a distance half, right. So at the geometric center, basically I am drawing the center of mass of each of these blocks. Okay, now I can draw this separately, okay, only drawing the center of mass of each of these blocks. So this is at a distance of L by 2, right, this is at a distance of L by 2. Now let's go, let's see for this one. This is at a distance of L by 2 plus L by 2, right, this is at a distance of L, if you see. Okay, so at a distance of L, we have one more mass m due to the second brick, and if you see, this is shifted, the above brick is shifted by length L by 4, okay, L by 4, if you see, it is shifted by a length L by 4 as compared to the second one, so its center is also shifted by L by 4. This is L, right, this is L, right, and for the last one it will be L plus L by 4, right, L, so it is, if you see, this is L plus L by 4, right, hope I am correct. So this is third mass. Now you can treat them as discrete mass and find the RCOM, the thing that we are supposed to find. Okay, so it is very simple now. RCOM is M1 R1 plus M2 R2 plus m3 r3 upon m1 plus m2 plus m3, right? So three discrete masses. So m1 is m, r at a distance of l by 2. This is again m at a distance of l, and this is again m at a distance of l plus l by 4, that is 5l by 4. And in the denominator we'll have 3m, m plus m plus m, 3m, right? So this m can cancel throughout, and we are left with what, 3 in the denominator, and we can take 4 as the LCM, so this will become 2l. So 4 will be multiplied over here, so you can compute, basically it's simple, and 4 as the LCM, so this is 4l, and this will remain as 5l. So this will give you this is 9, 9 plus 2, 11, 11 by 12 L. Is that an option? Yes, option D, right? So 11 L by 12. So that is the position of center of mass from the wall. We are not talking about the width, we are only talking about the length. Of course, if the width was given, we could also calculate in that direction also, okay? So that is not the point over here. Our answer is 11 by 12 times L. And as we go ahead, the questions will progressively get tougher. The first 1/3 section, that is from question 1 to question 10, was a bit easy. Now it's actually question 1 to 20 is from easy to moderate category. So you can expect easy to moderate questions in this 1 to 20 questions. Okay, last 10 questions will be moderate only. Okay, moderate to slightly difficult. Okay, because that is the level of BITSAT. So training you for the whole gradient of levels that could be asked in BITSAT. Okay, so that's about this question. Let's move to the next one. So question 12 over here, the temperature of an ideal gas is increased from 120 to 480 if at 120 Kelvin the root mean square velocity of the gas is V. You are supposed to tell, not V, it's U. You are supposed to tell what will be the velocity, the same RMS speed at 480 kelvins. Okay, it's very simple if you know the relation for RMS speed. Yes, of course, the paper is very simple if you know everything, but yeah, the question is very simple if you know it. So Vrms is under root 3 RT by N, right? So if you see over here, R is a constant, 3 is of course a constant, M is the mass of that gas molecule, so that is also constant. So only variable over here is that your Vrms is related to square root of T. Okay, so such type of questions are very important in BITSAT, okay, wherein you are supposed to manipulate the relation, like we saw in case of your current and drift speed, the ratio of kinetic energies, or this. Okay, so you are supposed to know the relations and use it to your advantage, okay, to solve the question. So Vrms for the, in first case, okay, we can say V1 and V2, and it is understood that it is the RMS value will be proportional to square root of T1 by T2, direct relation, right? So now if V1, so let us substitute, V1 is U, initially velocity U, final velocity we are supposed to find. In the second case, we are supposed to find the velocity, not final velocity. So T1, the temperature initially, so at 120 it is U, right? So 120 in the numerator. At 480 we are supposed to find. So 480 will give us V2, which we are supposed to find. Okay, this is 124, right? 12 4s are 48. So U by V2, this is 1 by square root of 4. So 1 by 4, that square root will give us 2, and V2 will be 2 times of U, right? 2 times of U. V2 will be 2 times of U. Okay, so yes, temperature is made, or you could directly see temperature is made 4 times. So your velocity will becomes root 4 times, which is 2 times. Okay, so that way you could also do it orally. Okay, so that was about this question. Over to the next one. So question 13 from ray optics. Now again, optics is also an important part. One question from ray optics and one from wave optics is fixed in whatever BITSAT paper that you answer. Okay, so and these topics, usually questions are asked from various aspects. Okay, so you are supposed to know these 2 chapters very thoroughly. Okay, let's come to this question. It's a simple one. Here you are given the wavelength of an incident light on air glass. So here you can just use the formula of refractive index. You are supposed to tell the wavelength of light in glass would be. glass refractive index is 1.5. This is wavelength in air, you are supposed to tell wavelength in glass given the refractive index. Okay, now you can use n is equal to c by v, right? Or you can see that v is equal to velocity is equal to velocity of your ray light is f lambda, right? Frequency into the wavelength. Okay, you can see that frequency does not change, right? Frequency depends on the source. Only the thing that is changing is velocity as your light moves from one medium to another. Okay, so and frequency does not change, which means your velocity is directly proportional to wavelength. Okay, so whatever happens with velocity is going to happen with your what we say, whatever happens with velocity will happen with your wavelength. Okay, if you see velocity becomes c by n, right? When this is the velocity in the medium, this is velocity speed of light in air, so air and medium, so velocity in the medium becomes c velocity in light divided by n. So similarly lambda will become lambda in lambda in the medium will become lambda divided by n. Okay, lambda in air divided by, this is in air, right? C is in air, so lambda in air by n, because direct relation, right? So lambda in air is 5460, and that you divide by 1.5. 1.5 is actually 3 by 2, or you could have just done 2/3 of that value to get you to the answer. 3 18s are, and this is 20s are 60, so 1820 into 2, 18 double is 36 and 20 double is 40, so 3640 angstroms. Okay, so option A, when in doubt choose option A, is your correct choice. Let's move to the next one. So in question 14 we are given the position of a projectile at t is equal to 0. It is launched at t is equal to 0 from origin, and this is the position at t is equal to 2 seconds. So this is the projectile at t is equal to 0. At t is equal to 2 seconds we have 40 I cap plus 50 j cap. Okay, so we are supposed to tell if the projectile was launched at an angle theta. Okay, the angle of launch is theta. You are supposed to tell what is this theta. Okay, g is taken to be 10. Okay, now how will you do this? Here we are given 2 points, but the origin is of no use. I was thinking of equation of trajectory, but I think we need to approach by the usual way. Okay, so here we have a projectile motion, we'll break it, which is launched with initial velocity u, making angle theta. So you can say that it is u sine theta in the y direction, right? Opposite to theta, sine theta, parallel to theta, cos theta. So u cos theta in the x direction, right? And if you see, we can now apply the equations in x and y direction, and we'll get to our answer. So in y direction, let us first apply that s is equal to ut plus half at square. Okay, so sy uy t plus half ay t square. Now t is, we are applying at t is equal to 2 seconds, because that is the position that we know, right? At t is equal to 2 seconds, your y is 50. Y is 50, right? X is 40, y is 50. So 50 uy, which is u sine theta, initial velocity in the y direction, into 2 plus half ay. Ay is taken to be 10 minus 10. Be very careful with the signs, you might end up at a different answer, right? One big lesson from math in life is to be careful about your signs. Okay, so this and this will get cancelled. 50 2u sine theta minus 20. Okay, so that will give you 2u sine theta. I am speaking Chinese. 2u sine theta is 70, and u sine theta will be 35. Right, so this is what we obtain from the y direction. Now from the x direction, we are going to obtain an equation for u cos theta, right? And in the x direction, if you see, it is basically speed is equal to distance into time, right? There is nothing, no acceleration in the x direction. Okay, it's basically speed is equal to distance into time. Now the acceleration in the x direction is 0. So sx is equal to ux into t. Okay, so displacement in the x direction 40, velocity u cos theta and time 2, right? So I can write 2 over here, and this will be 20 is equal to u cos theta. Now you can take the ratio, that will give you 10 theta, right? U cos theta by u sin theta will give you 10 theta, and that will give you 35 by 40, 35 by 20. Okay, so that is 5 sevens are, and this is 5 fours are, right? So 10 inverse of 7 by 4, that is that option C. Option C, 10 inverse of 7 by 4 is the correct choice over here. Let's move to the next question. Let's come to question 15. Here we have 4 massless springs which have force constant 2k, 2k, k and 2k. So they are arranged as shown. Okay, 2k, 2k, mass m, k and 2k. Okay, they are the mass is kept on a frictionless plane and it is displaced slightly in the horizontal direction. Then it will oscillate with certain time period, right, or certain frequency. You are supposed to tell what is the frequency of that system. Now this is very simple. Nu is given as 1 upon 2 pi under root k effective. I will write the effective spring constant divided by m, right, or the time period will be 2 pi under root m by k, right. So from there frequency is 1 upon 2 pi under root k by m. Okay, so the only objective over here is to find k effective, rest all we know, right. So k effective, if you see these two are in series, these two 2k 2k are in series. In series what happens, 2k and 2k in series, that will give k, right. It is opposite of that of resistor. It is like capacitor, you can think of that. Okay, so 2k 2k in series, basically it is product upon sum. So 2k divided by 2k plus 2k, which is 4k. Okay, so 1k cancels, 2 2 is 4, so here you will get k. So here you get k. And what about the other side? Other side they are in parallel, right. So they are in parallel, so k plus 2k simply, right. So here you will get 3k. Now what about this two? Okay, what about this and this? Are they in series or are they in parallel? Okay, we discussed it in the previous session. Okay, one of the videos in session 2 or session 1. Okay, we have discussed such a case wherein one spring was attached to this end and the other spring was attached to the other end. Okay, now since it is an end-to-end connection, you might say that it is series, but I am afraid to inform you that it is not, it is parallel. Okay, why? Because the differentiating factor is whether the force is equal or the displacement is equal. Okay, so if you see, if you displace it, so now finally we have k and 2k. Okay, this is an important point, that's why I am stressing on it. And here we have 3k, right. This is where we have reached. Okay, now to find k effective, you see, if we displace this by delta x, this will get, so if we stretch this by delta x, this will get compressed by delta x. So the extension is the same. Okay, value of extension is the same, which means they are in parallel combination. They are not in series. Okay, extension is same, meaning parallel combination. So you have to add this two. So this is 4k. Okay, so k effective is 4k. Plug in that value. So here we'll have 4k by m, right. 4k square root and this can cancel. It will come out as 2, right. So you'll have 1 upon pi under root k by m, which is option B. Okay, so option B is 1 upon pi under root k by m, which is the correct choice. Okay, over to the next question. Question 16, 12 electron volt energy is given to the electron in the third orbit of each atom. So you are supposed to find the energy of electron when it ionizes, okay, from the third orbit. Now in the third orbit, what will be the energy? Energy is given as minus 13.6 divided by n square, right. This is in eV for each atom. Now we have the electron in the third orbit. We don't ask why, because it is given. Okay, so n square, n is 3 in our case, and it is 9 over here. 3 square is 9, and if you calculate this, it will be 1, 9 ones are 9, that will give us 46, right. 9 5s are 45, 9 ones are then 1 1 1, right. So here we'll have 1.51 electron volts as the energy in the third orbit. Okay, this energy will bind your electron to the nucleus. Okay, it will keep it in that orbit. Now you supply 12 electron volts. Now the energy that you supply is 12 electron volts. Okay, and this energy is the binding energy. which keeps the electron in that orbit, right? So this energy, so the supplied energy minus the binding energy will give you the effective energy, which is the energy required to ionize. Okay, so this is the energy when we ionize it. So that will be what will be that? So that will be what will be that? That will be 10.49. Okay, right? So 12 minus 1, 11, 11 minus 0.51, 10.49. Okay, so that is your answer. Over to the next question. Let's come to question number 17. Let me break down the story for you. Long story short, we have a disk which is revolving. Okay, with this disk has a moment of inertia I1 about this axis, and the angular velocity, initial angular velocity of this disk is omega. Okay, it is revolving with angular velocity omega. Okay, we are going to put another disk of moment of inertia I2 about its particular axis. Okay, now this will have some final velocity, right? When you introduce another disk of moment of inertia I2, the velocity will change, right? Angular velocity will change. You are supposed to report what is the final angular velocity of this combination of disk. Initially it was I1 and it was omega. For I1 it was omega. Now you have introduced I2 without any external torque. Okay, that might give you a hint. So it's not mentioned in the question, by the way. You are supposed to know that it is without any torque, right? It's not mentioned. And I2 is introduced, then its angular velocity will change. What will be that? Okay, here you are just supposed to use conservation of angular momentum. Okay, so initial angular momentum is equal to final angular momentum. Initial angular momentum was I1 rotating with omega, right? Final angular momentum, we have I1 plus I2, they are along the same axis, so directly add them, and we omega final. Okay, you can clearly see that omega final is I1 omega upon I1 plus I2. Very simple, but if you do try it yourself and do see if you get to understand the language of this question, okay, because that is very important. Okay, you are supposed to know what is I1, for which one is moving with omega, what is introduced, and what will be the resultant velocity. Okay, if you mismatch that, you might end up on one of these options. Okay, so that's about this question, and this is from rolling rotational motion, right? That is also an mechanics chapter from mechanics, so it is also important. Usually questions from rotation motion are based on your pure rolling, and then we have down the incline, what we call that moment of inertia down the incline. Okay, so you'll have they will ask you to find the ratios of your acceleration of different bodies down the incline. Okay, so those type of questions are important. If you don't know what I'm speaking about, do check out the topic rolling down the incline, okay, of different of bodies with different moment of inertia. Okay, so that's question 17. Over to the next one. Question 18, this is from the chapter of waves, the 11th standard waves. Okay, and this is a question based on Doppler effect. Now Doppler effect is one of the favorite topic of your BITSAT among the many more. Okay, so if you get a question from waves 11th standard, it is highly probable that the question is based on Doppler effect. So emphasize on Doppler effect, do it thoroughly. Okay, this is one of the important topics for BITSAT. Okay, let's come to this question. The frequency of a whistle engine appears to be 4/5 of the initial frequency when it crosses a stationary observer. Okay, here the language is very important. This initial frequency is not the original frequency. Okay, mind you, it is not the original frequency. In the first case, initial meaning the observer is standing over here, stickman, and here we have our frequency. Okay, the engine which is moving with, it has some frequency f0, okay, with which it is blowing the whistle, and here it is moving with some speed, right? So when it is moving towards the observer will hear f1 dash, right? This frequency f0 will become f1 dash, and now it is moving, crosses the stationary observer, right? In the second case, this is the initial case. In the second case, the observer is there only, standing there only. Okay, I is this side. Okay, and this is crossing the observer. Again, of course, the frequency is f0. and it is moving with the same velocity, but here it is moving away from the observer. So the frequency observed by the observer will again change. Now it becomes f double dash. Okay, so this ratio is 4 by 5 or 5 by 4. Okay, we'll see that. So let's come to this one. Here the f dash can be written as in terms of f naught, right, using Doppler's effect now. Okay, f dash I have to write in terms of original frequency f naught. So we'll have v, and we have observer and source, right? Observer on top and source. Now observer is at rest, right? So we need not consider the observer. Okay, we'll simply write v in the numerator. What about the source? Is it a plus sign or is it a minus sign? Now the source is moving towards the observer, meaning it wants to increase the frequency, increase the f dash by decreasing the denominator. Increase f dash by decreasing the denominator. So this is our f dash. Now f double dash will be f double dash, again you can write it in terms of f naught, the original frequency, and in the numerator we'll have v only. In the denominator what will happen, we'll have v. Now it is moving away from the observer, so it will try to decrease the frequency. It's just opposite of that case, so v plus vs. Okay, so it is moving away, so it will try to increase the denominator and decrease this frequency. Okay, so now you can take the ratio. So that will give you f dash by f double dash. This v f naught is common. So this is inversely related to v minus vs. This is inversely related to v plus vs. Okay, now solve this equation. Now you already know that this ratio is 4:5, 4/5 of the initial, right? This is the initial frequency f dash, and your f double dash is 4/5 of your initial frequency. So f dash is the initial frequency and f double dash is 4/5 of f dash. Okay, or you can see this in the numerator we have v plus vs and it is v minus vs. So in the numerator bigger number, so this ratio will be 5 by 4. Okay, please don't confuse with that, otherwise you might not get the answer, v minus vs. So initial is f dash, this is the second case, right? So this becomes 4/5 of the initial. Clear? So this is 5 by 4 is v plus vs on v minus vs. Okay, so 5v minus 5vs, I'll substitute the values later. 4v plus 4vs. We are supposed to find the velocity of the source, the engine, right? So this we can take to the other side. This is 9vs and this will be simply v, right? 5v minus 4v, v is 330 and this is 9 and this will give us vs. So 9 3s are 27, right? And we'll have 3s are, so 27 plus 6 remains 9. How much is a 60? 9 6 is a 54. Okay, 54, and again 6 remains, so 6 36.666. Okay, 36.6. Where is that? Option B. Okay, so Doppler's effect, our answer of the source, the velocity of the source is 36.6 meters per second. I hope the approach is clear. Let's move to question number 19. Question 19 from the chapter of gravitation. Here we have if the earth is 1/4 of its present distance from the sun, you are supposed to tell what will be the duration of the year. Okay, why is the duration of the present year? Very simple, use Kepler's third law, time period is directly proportional to radius cube, right? Such type of questions, I told you, very important, ratio of the kinetic energies, or the time period is half, or the distance is half, what will become to the time period, RMS speed dependent on temperature. So you should know this, all these relations, and you should know to find the ratios and find what happens to one quantity when other is changed. Okay, those type of questions are very common in BITSAT. So T1 by T2 we can say is R1 by R2 cube, this square, right? So T1 initially the year is Y. Okay, new year will be, let's say, T. Okay, we are supposed to find T in terms of Y. R1 is the present distance, we'll consider it as R. Then R2, if the earth is 1/4 of its present distance, so R2 becomes R by 4, and this is cubed, this and this will get cancelled. Y by T square is 1, so that 4 will go in the numerator, right? 4 cube, that is 4 4s are 16, 16 4s are 64, y by t the square, or you can see t square will be y square by 64, right? T square will be y square by 64, so t will be y by 8, right? 64 root is 8, so option B, the year will become 1/8 of the original year. Okay, so that is our answer. Over to the next one. So question 20 over here, a metal disc of radius 100 centimeter is rotated at a constant speed, that is omega, in a plane right angles to an external magnetic field. Actually this is a question which is uh, available in a general format in your NCERT, and they have picked it up from there. So they have just given you values and you are supposed to calculate the EMF induced. Okay, the magnetic induction, the magnetic field is given as 0.05 Weber per meter square. Okay, they have discussed this problem in NCERT, and actually the NCERT tries to find the value for EMF in terms of general terms. Okay, they derive the value for EMF, and that value is obtained as, they have a short derivation. You can check out your NCERT. It is in one of the examples. Okay, the answer is, some of you might know it and it's good. It is PR square omega. Okay, half b r square omega for a disk which is rotated in a magnetic field. Okay, so here you are supposed to find the EMF. Okay, so this is the expression for that, and let us now substitute and find the values, right? So directly a formula based question, right, if you know it. Otherwise you can derive using integration or refer NCERT. So r square will be 1 meter, right? This 100 centimeter is 1 meter, omega is 60. So this is 60, that is 30, 30 and 0.5 is half, and 1 0 will cancel with that. So half of 3 is 1.5, 1.5 volts. Option B, 1.5 volts. Okay, so that is our answer. You can do the derivation by integration, I believe. Okay, so that's question 20. Over to the slightly moderate to difficult part of this lecture. So question 21 over here, this is a good one. We are told that if a liquid drop breaks into small droplet, it results in the lowering of the temperature. So such a case, we have a drop, a bigger drop of radius capital R. It breaks into n small drops, capital N small drops, each of radius R, small r. Okay, then the decrease in temperature. Okay, here you are also given as specific heat capacity of that drop, and T is the surface tension of the liquid. Okay. Now, first of all, you can do it by a very typical method. So, first of all, the volume will remain same. So, we can equate the volume of the big drop. Volume of the big drop is equal to volume of the n times the small drop. Okay. So, volume of the big drop is 4 upon 3 pi r cube. From here, we will get a relation in n, capital R and small r. Okay. So, here 4 by 3 pi r cube, small r cube, right? So 4 by 3 pi, 4 by 3 pi gets cancelled. N will be nothing but capital R by small r, the whole cube, right? So capital by small r cube. Okay, so that is the value of n. Okay, we'll be using it somewhere, since the in our option n does not appear. Okay, we'll have to substitute for n. Okay, and now this lowering in temperature is due to surface energy. Okay, surface energy, how is that defined? That energy is basically your surface tension times area, right? I'll use A because S is used for your specific heat. Okay, so this surface energy will be T times your surface area, change in surface area. Okay, so initially surface area is 4 pi capital R square, right? This is the initial surface area, right? And in the second case, we have n small droplets of again 4 pi small r square. Okay, here you can substitute for n, but we'll do it later. Okay, so this is the surface energy. Now this energy is the energy that results in lowering of temperature. Okay, now you can use the formula for specific heat. This was the actual hint, okay, that you are supposed to use specific heat formula. It says specific heat is basically the heat required to change unit temperature, right, for some amount of substance. So we can find delta T from here, or delta theta I shall say. T I have used for surface tension. Okay, so delta theta change in temperature will be nothing but Q by ms. This heat is nothing but change in surface energy. Okay, the lowering in temperature is due to surface energy. Okay, so surface energy is T into 4 pi r square minus n times 4 pi small r square. Okay, and what about m? Mass of the drop. Mass of drop, now this is for the bigger drop, lowering in the decrease in temperature of the drop. Okay, single drop, not the droplets. So m is the bigger drop, 4 upon 3 pi r cube. Now mass is density into volume, right? So density of the liquid, we'll take it as rho. Here also rho is there in the formula. So rho is that density of that liquid and times volume. Okay, and s will keep as it is. So if you see 4 pi, 4 pi, 4 pi can get cancelled. This 3 will go on top. So we have 3t by rho s. Okay, 3t by rho s. It's matching with this one and this one. Let's see which one is correct. And we'll have r square minus n times 4 pi, sorry, not 4 pi, r square, right? And upon r cube we have. Okay, let's solve it further over here. So delta theta will be 3t by rho s, and if I take it, if I separate it, separate the denominator, which each of these terms, what am I saying, we'll get 1 by r over here, and this will be n r square by r cube. Right now n we can substitute as r cube by r cube. So this r cube gets cancelled, and we are left with 3t rho s 1 by capital R minus 1 by this r square, and this will also get cancelled, 1 by small r. Okay, 3t by rho s 1 by capital R minus 1 by small r. Let me verify that. Yes, option D is correct. Okay, option D is the correct choice over here. Let's move to the next question. So question 7, we are given the BH curves or the hysteresis loop of sample x and y of ion. You are supposed to tell which of the following is correct. Okay, you are supposed to tell which will act as a electromagnet and which will be a permanent magnet. Okay, so for permanent magnet we want high retentivity, okay, and high coercivity. Okay, this is a question from magnetic properties of matter, right? Not usually asked in BITSAT, once in a while. Okay, once in 2-3 years. Okay, so but yeah, I just wanted to give you a taste of that too. So here permanent magnet, for permanent magnet we want both retentivity and coercivity to be high. Basically it means these values, right? This is the retentivity, this is coercivity, retentivity, coercivity. Okay, so you can see that this is true in sample X. Right, for sample Y the coercivity value is very low, retentivity is almost comparable, coercivity is very low. Okay, so if you want your material to be permanent magnet, coercivity should be high, right? There when you apply reverse current, the magnetism should not die easily. Okay, so C should be high, which is in the case of sample X. Okay, this you can see in sample X. Now coming to electromagnets. So for that also retentivity there is no issue. Coercivity should be low actually for electromagnets, and one more important condition is that area of BH curve should be less. Area of BH curve should be less. Okay, and this is satisfied via sample Y, if you see, right? Because coercivity is less in this case and area of hysteresis is less. Actually the area in the hysteresis curve corresponds to the energy density, right? Energy dissipated per unit volume. So that should be less for a electromagnet, right? So it should not cause a lot of loss of energy. Okay, so here if you see, sample X is a permanent magnet and sample Y is a electromagnet, which is option C. Okay, so that is correct. Over to the next question. Question 23, here we have a radioactive material with activity A1 at time T1. Okay, the radioactive material activity is at time A1 it is A1, and at later time T2 it is A2. Yes, if the decay constant is lambda, you are supposed to tell what is the relation between A1 and A2. Now activity is defined as lambda times L, right? So at T1 we can write, and at T2 we can. It's very simple. So at T1 we have A1 is equal to lambda is constant, decay constant. So n we can write it as n0 e raised lambda n0 e raised to minus lambda t, right, in general ways. So this will become n0 e raised to minus lambda t1, right, at time t1. Similarly, A2 will become lambda n0 e raised to minus lambda t2. This is at t2. Okay, this is t1, this is at t2. Okay, you can divide this two. So A1 by A2, you will get this and this will get cancelled. E raised to power minus lambda t1 you will have, and in the denominator e raised to power minus lambda t2. So A1 will be A2, can bring the denominator in the numerator, and this will become plus, right, minus lambda will become plus. And here if we take minus lambda common, we'll be left with t1 minus t2, right, minus lambda we are taking common, so minus and minus plus, right. So this is the answer that we get, A1 as A2 e raised to minus lambda T1 minus T2. So this one, option A. When in doubt, choose option A. Okay. So yeah, that is question 23, and a few more questions to go. So let's pull up our socks and let's get that done. Question 24 over here. In this question we have a rubber cord with area that, and its length is 0.1 meters. It is stretched to this length now. Okay, so if you find the difference between that will give you delta L or delta X. Okay, so due to this stretching there will be potential energy in the rubber, right? So that potential energy is used to release a particle of mass 5 grams. Okay, you are supposed to tell the velocity of the projectile. Okay, Young's modulus of rubber is also given. Okay, so I told you that the potential energy of kx square will give rise to this motion, right, motion of the particle. So the potential energy of in the string or in the rubber will result to kinetic energy of the particle. You can cancel half on both sides. So from here we are supposed to find V. Okay, we are supposed to find V. So first of all, we know delta x is this minus this. Okay, k we need to find, m we know. Okay, so how will we find k? We can use Young's modulus. Young's modulus says that what is the relation for Young's modulus? FL by A delta L, right? Stress upon change in dimension to original dimension. Stress is force upon area, change in dimension to original dimension. FL by A delta L, if you remember the song. Okay, FL by A delta L. Okay, so now this delta L is nothing but the stretch length. Stretching, we have taken it as delta x. You can take delta x or delta L. The notation does not matter. What we can do next, now the rubber is like a spring. You can treat it like a spring. So you can write F is equal to K delta x, magnitude wise. Okay, and here we have L A delta x. So this delta x and delta x will cancel, and you will get K is equal to Ya by L. Some of you might directly know this relation, that K is Ya by L. The restoring constant is Ya by L. Okay, if you know, good for you. Just substitute the values and obtain the value of K. So K is Y, which is this. Area is 10 to the power minus 6, and length is 0.1 meters. Okay, actual length. Okay, this is stretched length. Actual length is 0.1 meters, which is 10 to the power minus 1. 10 to the power minus 1 will cancel with one of this, so it will make it 10 to the power minus 5. Minus 5 plus 8 plus 3, right? Or I can write it as 5000. Okay, so K is 5000. K is 5000. Delta x is, if you see over here, delta x is this minus this, right? So it is 0.125 minus 0.1. So that is 0.025, right? And here we have m. M we can take it over here since we want V. Okay, m will be 5 grams. So 5 into 10 to the power minus 3. Okay, so this 5 can get cancelled. This is 1000. 1000 is 10 to the power 3, and this also goes on top, 10 to the power 6. And this is, I can write this in orders of 10. 2.5 into 10 to the power minus 2 squared. Okay, this is V square. Now take a square root, 10 to the power 6 will become 10 to the power 3. This whole is squared, so you just write it once. Okay, so this gives you 2.5 into 10, right? 2.5 into 10, which is 25. So 25 meters per second, right? Everything is in SI units, so 25 meters per second. So option C is the correct choice over here. You were supposed to know this value, or you can do a short derivation. K is equal to YA by L. Use that K in potential energy, equate it to kinetic energy, find V. That was the approach. Okay. So let's move to the next question, which is question 25. Let's come to question number 25, which is a good question from your Newton's laws of motion. Okay, so here we have block A and B kept on a wedge, triangular wedge. The inclination is 45 degrees. All the assumptions are made that the string is massless, inextensible, and the surfaces are frictionless. Okay, so the coefficient of friction between block A and the wedge is 2 by 3, and that for block B and wedge is 1 by 3. Okay, then both of them are released from rest. So if you are holding them, you just release them from rest. You are supposed to tell what will be the acceleration of block A. Now the straightforward approach of doing this question is to write equation of motion for block A and block B. Okay, assume that it will slide down, the block B will slide down and this will slide up, and accordingly write the equation of motion, solve for A, acceleration. Okay, both of them will have the same acceleration because it's a constrained motion in extensible string joint. So if this is A, that will also be A. Okay, so solve the equation of motion, find the value of A, and it will come out to be 0. Okay, and that is how I'm not going to do it. I'm going to do it by a different way. Actually this is very risky. Okay, this will work because here the answer comes out to be 0. So actually we can verify that by looking at the frictional force. Okay, if you see the frictional force will be acting now, this block has tendency of going down, so this will act in the above direction, and this will also act up the incline. Okay, so the total frictional force you can add it. Okay, what is the maximum total frictional force that we get? Okay, so the total frictional force, let us find that out. It will be mu n, right? Friction force is given as mu n. Okay, normal force. Here the normal force will be, so for block A, let's write for block A, mu A, mass of A into G cos 45, right? Because n will be mg cos 45, right? Because perpendicular to the incline we have cos theta, so mg cos theta, and along the incline we have mg sin theta. Normal force is perpendicular to the incline, so n is mg cos 45. Okay, and similarly for the block B we have mass B g cos 45. Okay, so mu A is 2 by 3, it's given. Mass of A is m, cos 45 1 by root 2. Okay, mu B is 1 by 3, mass is 2m, and of course we have a g over here, and 1 by root 2. Okay, if you see in the denominator we have 3 by root 2, and 2 mg plus 2 mg, that is 4 mg. This is the total frictional force that is holding your blocks on the incline. Okay, so your net pulling force, which will be 2 mg. So if you assume it will move like this, so if you see the net force will be 2 mg. Tension is a internal force. Okay, it will not contribute, so you only have to see at the net force. So this is mg sin 45, 2 mg sin 45, and this is mg sin 45. Okay, this is along this direction, these are along opposite directions. Okay, so 2 mg minus mg sin 45, that is your net force. You can show that this force will be less than this, hence frictional force is more, meaning there will be no motion, right? Friction is more than your F net, then there is no motion. Okay, so here we'll have 2 mg sin 45, I can directly write it as 1 by root 2, and minus mg. Friction actually acting will be equal to F net, but here this is the maximum friction that can be present. Okay, this is the maximum limit. Since here the force is less than that maximum limit, the frictional force will be equal to this net force, because frictional force is variable. It will equal this force and there will be no motion. Okay, that is the actual concept. Here we'll get mg by root 2. Okay, if you see, this is 4 mg by 3, and this is around 4 by 3 is 1.33, right? Okay, so this is mg by root 2. So this is 1.33 times mg by root 2, and this is mg by root 2. Okay, so ft, the frictional force, is greater than f net, no motion, no acceleration. Okay, since the system is initially at rest, released from rest, then it will remain at rest, right? No motion, no acceleration. So that is question 25. Over to the next one. So question 26, this is based on your meter bridge. Usually questions from the experimental side based on meter bridge, potentiometer, or your vernier caliper and micrometer screw gauge are not asked for BITSAT. Once in a while, once in a blue moon, they will ask, like in maybe 5 years time. Okay, so but still it is, I'm preparing you for anything that is about to come. Okay, so here we have a question on meter bridge. This is the one that we are going to do in the entire series. So here meter bridge, here we have null deflection at AC. This corresponds to a value of x. So at x we have null deflection. What would be the value of the null deflection if the radius of the wire AB is double? If AB radius, the radius of the wire AB is double, then what will happen to the null deflection? That is the question. Okay, and logically the answer should be it should not change, right? Because if you change the radius, what will happen? Basically, of course, the RAC will change, RAC and RBC will change, right? This both will change, of course, because radius is your resistance is inversely proportional to length, right? It's L by A. But what will happen? AC, so suppose radius is, what we say, radius is double. So area is proportional to radius square. So your new resistance will become R by 4. New R dash AC will become RAC by 4. And similarly R dash BC will become RBC by 4. Okay, but since they are in ratio, since this concept is itself based on your Wheatstone balance bridge, so R1 by RAC is equal to R2 by RBC, or we can write it as R1 by R2 is RAC by RBC. Okay, so since you can see that both of them are divided by a factor of 4, so factor of 4, and since this is proportional to length, we can write like this, right? X and 100 minus x. This length for AC is x and for BC is 100 minus x, meter bridge, right? So total is 100, this is minus x in centimeters. Okay, so both are divided by a factor of 4, so R1 by R2 effectively does not change, so x effectively does not change. Okay, so even if you double the radius of this wire, the null deflection point will not change. Okay, key point. Let's move to the next question. Let's come to question number 27. Here we have a solenoid of length 2 meters and diameter is 3 centimeter. This is useless, or this is just given to show you that the radius is very much small as compared to the length. Okay, now this solenoid has 5 layers of winding with 1000 turns each. So effectively 5 times 1000, 5000 turns, and carries a current of 5 amperes. What is the magnetic field at its center? Now magnetic field at the center of a solenoid is given as mu 0 Ni. Now this n, small n, is not number of turns, it is number of turns per unit length. Okay, and now substitute all the values. Mu naught is 10 to the power 4 pi into 10 to the power minus 7. Number of turns, I told you it is 5 times 5 layers and 1000 turns each. So 5 times 1000 is 5000, of course. So 5 into 10 to the power 3. Length is 2 meters, 2, and I current is 5 amperes. Okay, now what can we cancel? This and this we can cancel. We'll have pi and we'll have 10 to the power minus 4 we can get, and also 5 to the is 10. This 5 I'll write over here. 5 to the 10, and this 10, okay, we can make it 10 to the power minus 3. Okay, this is 10 to the power 3, that would make it 10 to the power minus 4, 5 2s are 10, 10 to the power minus 3. Okay, 5 pi. 5 pi is actually 3.14, right? 5 pi will be something 15 point, right? 15 point actually 1.57. So options, seeing the options, that will be 15 point, right? 15.7, let's say. Okay, so that will be into 10 to the power minus 3, or we want it in the scientific form. So 1.5 into 10 to the power minus 2, which is option C. Okay, so option C is the correct choice over here. Over to the last two questions for the day. Question 28, again a question on Doppler's effect. So here we have a submarine A which is being, okay, that is not a submarine, submarine A which is being chased by a submarine B. Okay, so submarine A is moving with a velocity of 17 meters per second. This is moving with 34 meters per second. Okay, and this is emitting a sound frequency of what is the frequency? 600 hertz. So original frequency is 600 hertz. Okay, then this frequency is released so that this ship submarine B, which is chasing the submarine A, can receive some information, can detect the ship A. Okay, to detect A. So basically this frequency will go and hit the submarine A and it will come back to submarine B. Okay, so that is the process which is going to go on over here. So you are supposed to tell the basically the final frequency which is received by your, so received by submarine B. Okay, so finally it's reflected and received, right? So the final frequency that is received after reflection from the submarine A. Okay, now first of all there will be this frequency f dash, which is the frequency heard by A. Okay, now then A will act as source, and we can consider that the reflected waves are what can we say, reflected waves are from A. Okay, we can consider A to be the source in the second case. Let's do the first thing first. F dash. F dash is the frequency heard by A, as seen by A, right? As seen by A. Okay, so suppose you were in ship A, this is the frequency sent by ship B. Okay, what will you hear? That is the first thing that we are going to do. So the format is simple: observer on top, source below, original frequency. Okay, now you have to think. Okay, so what is the observer trying to do? Observer is trying to run away. Run away meaning it wants to decrease the frequency, so it is decreasing the numerator. Now what is the source trying to do? Source is B in the first case, right? So source is B. What is the source trying to do? Source is trying to approach the observer, right? So it is trying to increase the frequency. Increase the frequency by decreasing the denominator. Okay, be very careful over here. So substitute the values: 1500, observer A 17, and 1500 minus B, velocity of B, which is 34, and F naught. F naught is 600. Okay, so if you solve this, okay, you can approximate, basically you will get something like 606.95, I believe. Okay, so this is the frequency heard by A. Okay, now this frequency will be reflected by A. Okay, and this you can treat A as a source now. Okay, because B is going to receive the frequency again, right? It is going to hit the frequency starts from here, sound waves start from here, go to submarine B, hit submarine B, and are reflected from submarine B. Right, now we can assume that A is acting as a source now. Okay, we can see that now as seen by B, as seen by B, reflected, seen by B, this is the reflected case. Okay, reflected by A. So A will act as a source, right? So F double dash, this is as seen by B, A acting as source. Okay, this is the wave frequency which the submarine B will receive. Okay, again the same format. Here the reflected frequency are F dash. Okay, F dash is reflected from A, right? So here V, VO, V, VS. Now be very careful. Who is the observer and who is the source? I told you A is reflecting, so B is observing, right? In second case, B is receiving the signal. So B is acting as a observer in this case. Okay, so observer, what is observer doing? Observer is trying to approach, right? Approach the source. Observer is trying to approach the source. It will try to increase the frequency, increase plus sign. Similarly, what is the source doing? The source is moving away from the observer. Observer is B, source is A. In our second case, observer is moving away from the source is moving away from the observer. So it is trying to decrease the frequency. Decrease the frequency, increase the denominator. Okay, so again, so here 1500 plus VO observer. Okay, very careful while substituting also. Source, sorry, did I make a mistake? Observer is this one, right? And source is this one, 70. Source is this one in the second case. F dash is 606.9. Okay, so that will give us about 613. Okay, 613.7, which is option A. Okay, even the options were very bold over here. Okay, you could actually neglect them. If you see this is very much high, okay, you cannot obtain such frequencies at such low speeds. Okay, such difference in frequency 600 to 6000, this can't happen. Also, this is extreme. This is 1/10 of that, right? This is 110 times, this is 1/10. Then again, this is okay, only competitor is this. Okay, this, it can be among these two, and that too this one is closer, right? So you could take a guess between this and this and say that that one is closer. Usually the difference in Doppler frequency, okay, between the original and the final one is very small. Okay, very small, not very large. So 600 to 613 sounds reasonable, right? This is also a difference of about 61, which is more. Okay, so that is question 28 for you. We'll do one more question, which I'll be doing, question 29. So I was not wrong when I said two more questions to go, and question 30 will be your homework question. Okay, so let's wrap it up soon. So question 29 over here, this is a good question. It's from wave optics. Okay, it will slightly require more concepts, a few more ideas from your brain to crack it. Okay, so there will be such a question or a two in your BITSAT paper which will be hard to crack. Okay, so if you know it, go for it, but it will take time. You can actually mark it for review and come back to those questions later. Okay, that is the tip. There will be 1 to 2 questions of this sort, okay, which will be actually difficult to crack. Okay, so let's come to this one. Here we have a point source S, which is placed between two mirrors at a distance d from the top one and at a distance of 3d from the bottom one. The distance from the screen, this is the screen, is capital D. Okay, you are told that d is very much greater than this small d, and this d is greater than the lambda. Okay, lambda is the wavelength which this source is emitting. Now you are told that this will form an interference pattern over here on the screen, and the rays only reach the screen, the light reaches the screen only after reflection. Okay, so there is reflection from this mirror and then it is reaching the screen. Okay, not directly. Okay, so hence there is interference. Okay, now you can try it yourself. Okay, you can pause the video here and try it yourself. I'll tell you the hint. First of all, it is given that the point P is second maxima. Okay, so that is some information that we can use. So delta x, which is the path difference, we can say at point P, basically I'm saying, is 2 lambda, right? This is at P. Okay, the path difference at P will be 2 lambda because delta x is n lambda, right? So n lambda for a bright fringe maxima, right? So 2 lambda. Now it is mentioned in the question that this happens only for your after reflection, right? The light reaches the screen only after reflection. So we can assume, instead of this mirror and source, this S source, we can assume two virtual sources. Okay, one, these are plane mirrors, right? This is the first mirror. So this is at a distance D. So this will be S1, we can say S1, source slit S1 we can say. So that will be at a distance D inside the mirror. Similarly, this source is at a distance 3D from the bottom mirror. So here we'll have a slit S2, source S2, S2 virtual sources we can call them, at a distance 3D inside the mirror. Okay, so you can see that this is also D. Okay, so that we get the total distance between the slits. This is 3D, right? So you can see that the distance between the slits is 8D, right? 3D, 3D, 6D, and this is 2D, 8D. Okay, so you can draw somewhat system like this, right? S1, S2, and the distance between the slits is 8D. Okay, and now you can see the diffraction, why it is happening, right? So this can be treated as two sources, and then it is coming at point P. Okay, now our objective is to find lambda, right? What is the value of lambda in terms of small d and capital D? Now when we have the equation for part difference, we can also have a equation for part difference again in terms of capital D and small d. How is that? We can use the Bragg's law. Delta x is d sine theta, right? Sine theta, theta is the angle. If you say, so this is the center, right? Center between the two slits. Here you will have the maxima because there is central maxima, right? Because this is both the part difference will be 0. Both the rays travel the same distance, right? So D will be what? So any point, suppose any random point P over here, this will be, this is point P, this is the distance theta, right? It will be here capital D, and here it is some y, okay, y. Okay, so that we are supposed to find now. This is point P. Okay, can we do something to find that? I can draw it here. Okay, so this we know that S1 is over here, S2 is over here. The difference between them is 8D, right? 8D. Now 4D will be their center, right? This is 3D and one more D. So here is somewhere their center. Okay, although it's not looking proper over here, let's draw it over here. 3D plus somewhat D. This is 4D. You can see. You can see it somewhere over here, right? So this is their center. If you see, right, this is somewhat their center. Okay, it will be exactly, but I'm not drawn it exactly, so up to the scale. So this will be the central maxima because the rays from here and here will have no part difference. So this is the central maxima, and this is our point P. This is our point P. Okay, so let's draw and connect this point just like we connected the center of the two slits to the point P. Now you can find this theta, right? This theta is simple to find now. It is, if you see, this distance will be, this is total distance is 4D, right? Between two mirrors is 4D. This is D, I told you, because this is 4D, this is 3D, so this is D, right? This is D and this is 3D, so total it's 4D. So you can see that this distance will be 3D, right? Total distance is 4D minus D, 3D. And this distance, actually it's from here, right? Actually it's from here, will be capital D. Okay, I hope I didn't make a mess out of it. I hope it is clear. So this distance is capital D. So this is 4D, I told you. So from here I connected. This will give us theta. This is 4D minus D, right? Sorry, 4D minus D. So this distance is 3D and this distance is capital D. Actually it's from here, so it is capital D. Okay, so you can see that sine theta will be nothing but opposite, which is 3D upon capital D. Okay, I was actually confused. Why is it 3D upon? Okay, theta is very small since these conditions held. Theta is very small, so sine theta is equal to theta or equal to tan theta. So basically you can substitute sine theta for tan theta. Okay, so we can write this. Yes, it is correct. Okay, don't worry. And here, so delta x will be d into 3d divided by d, right? d sine theta, d into 3d by, so this d is d dash we can write, right? This d is the difference between the slit. Okay, so it is 8d in our case. Okay, I hope you are not confused. This d is the x, delta x is equal to d sine theta. This d is the difference between the slits, right? So it will be 8d. Okay, s1 and s2. What is the difference? 8d. Okay, so here we get delta x as 24 d square by capital D. Of course, you are supposed to find lambda, so equate it to this, to lambda, right? So this will be 12d square by capital D, 12d square by capital D. I hope the approach is clear. Let me just go through it once. So here we have source S, so we make two virtual sources out of it, S1 and S2, that will act as slits. We saw that the distance between them is 8d. First of all, we wrote delta x is equal to 2d because that is the point of second maxima is given. Okay, so we'll also find this point P using the diffraction rule. Okay, delta x is equal to d sine theta. D is the distance between two slits, which is 8d. Now our objective is to find sine theta or tan theta. Okay, because the angle is very small. Okay, these conditions are held, so angle is very small. Sine theta is equal to tan theta. Okay, so that was the whole thing that we did over here to find sine theta. Okay, so we found the center of the slit, which is at 4d, 3d plus d. Okay, so this distance will be 3d because this is 4d minus d, 4d minus d, 3d, and the distance from the source to the screen is capital D, right? Distance from the source to the screen, capital D. So that is opposite upon hypotenuse, opposite upon hypotenuse. Okay, so that we substituted over here, got delta x, equated this to delta x and found lambda. So that was the whole idea behind this. I hope you were able to grasp this question. Let's move to the last question, which will be the homework question for the day. Question 30 over here. This is the last question for the day and I'm not going to do it. This is your job. This is your homework question. Okay, you can pause the video over here and take a screenshot. Okay, so do try it and let me know the answers in the comment section of this video. If you made it this far in this video, smash that like button and consider subscribing to join this series for free and join me around the next time. Okay, and let's crack BITSAT 2024. So with that being said, this is me signing off today. Keep enjoying physics.